finally, Wolf, why don't you introduce yourself, and then why don't you take over the screen and start us off with an intro?
Sure, great. Thank you, Christopher. So I'm Wolf McNally. I am Blockchain Commons lead researcher, technical researcher. I've written a lot of the specifications that, in collaboration, of course, with members of the community that we were promulgating. I've written a lot of the libraries and reference code, a lot of it in Swift, some of it in C and C++. I've also done some work in Rust and many other languages over the years. I'm an iOS developer. I've written many apps. And I was responsible originally for taking the Csr secret sharing code in its kind of raw form and turning it into the SSKR reference library, which people are starting to adopt, as well as, I basically created the UR specification for Blockchain Commons, as well as LifeHash, which is a visual hash algorithm. With that, Christopher wanted me to present a short stack of slides that I have talking about something that seems relevant to this conversation. Obviously, we're talking about collaborative seed recovery, which generally involves using Csr secret sharing and a tool like SSKR to split a secret into multiple pieces or shards, shares. I mean, that is. So sharding is this is a pet peeve of mine. Sharding is a verb. Share is a noun. So you shard a secret into shares that you then share out. And this is also called a deck of shares. The mechanism to do that currently as SSKR is only suitable for very short secrets. Seed tool, a Gordian seed tool, which I wrote, which is a secure seed management tool, can also derive keys and so on, and can also help you back up your seeds by using SSKR, splits the seed into several shares, but these shares are necessarily small because that's all the algorithm can handle. The algorithm can also handle splitting up a symmetric key, and this can be leveraged for larger payloads. And my understanding is this audience is very interested in being able to split larger payloads and then collaboratively share them out and then recover them. So Christopher asked me to produce a small presentation, and assuming I have the ability to share my screen now, I'm going to do that. Here we go. And get into this presentation about something we call crypto envelope. As you may know, a number of the UR or uniform resource specifications begin with crypto. We've been creating them at Blockchain Commons. So this is crypto envelope, and so I'm going to basically talk a little bit about its purpose and the possibilities for it, and then how specifically it relates to this conversation, because it's actually a bigger thing than just this conversation. But I want to make sure it's relatable to this conversation. So we call it envelope for very good reasons, and I want to work with analogies of an actual physical envelope. We're all familiar with the humble envelope. We've used it, for years and years, all our lives. But we really think about all the different ways we use it. So let's start by considering what you'd put into an envelope. The contents of an envelope can be something that is obviously very straightforward, very easy to read, intended to be read by anyone, or at least whoever opens the envelope. This is probably the most straightforward traditional use of an envelope. But you can also use an envelope to carry other kinds of contents, like encrypted contents which are meant for somebody who has a key or some way of decrypting the contents. Envelopes can also be used to hold things like certificates. Certificates warrant that something else is true about something and may carry their own kinds of authentication, signatories, things like that on them. Another thing that you could put inside an envelope is a small piece of data, like a QR code. This is actually an example of a UR request for an output descriptor. We're working on another app right now called Gordian Coordinator, which is a multi-sig partially signed Bitcoin transaction coordinator. And again, it's a reference tool. It's not meant to be a commercial product on its own. It's meant to be something that people study and use and adopt the technologies therein. So it can be a small piece of data like this, or it can be a large piece of data. There's no reason why you can't put volumes inside an envelope. So now we consider what can be on the inside of an envelope, what can be on the outside of an envelope. Well, typically envelopes are marked with things like who's sending it, who's the recipient, but you can also have other kinds of permits or warrants on it, like the stamp that indicates that you have permission to mail it, or the cancellation mark, which indicates that it was mailed. So there's these kinds of metadata on the outside of the envelope that goes along with whatever happens to be in the contents. Another thing that can be on the outside of an envelope is things that have to do with policy, like who who gets to read it, under what circumstances should it be used, things like that, business rules. Another thing you can find on the outside of an envelope are seals, things that can only be that basically authenticate the contents of the envelope, and can only be created by certain parties. Envelopes themselves can hide what's inside them. Often, when you use a security envelope, you don't want people to see what's inside the envelope unless they open it. This can be carried to any extreme you want, making sure the envelope is opaque to various kinds of inspection. And obviously, this corresponds to encryption in our digital space. But envelopes can also be used to selectively reveal parts of information that is inside them. And in some cases, you want to reveal a lot about what's inside it. You want to be very transparent about the contents without actually letting you touch or use it unless you can actually open the envelope. Very often you want to lock an envelope and make sure that only people with certain credentials can get inside the envelope, because whatever inside it is valuable. And another thing we don't think about too often, but we're all familiar with it, is that you can put an envelope inside an envelope. The self-addressed stamped envelope being a good example. And of course, there's no reason why you couldn't carry this on ad infinitum and put envelopes inside of envelopes inside of envelopes if you really wanted to. And in fact, there might be good reasons to do this under certain circumstances, especially in the digital world. So having kind of done that little survey, there's no reason why you wouldn't want to at times mix and match these things. You might want, for example, an envelope that shows its contents but also carries a seal, or maybe an envelope that shows its contents but carries a lock that can only be opened by certain people. So in other words, you can do a lot with envelopes, ranging from very simple to very complex. And as Alan Kay, a computer scientist I admire, said, simple things should be simple and complex things should be possible. So that's a value we have at Blockchain Commons. We want to make sure that the technologies that we invent with both serve the needs of the community and are things where, like for example, the UR kit that I worked on creating, it's simple to use from an adoption point of view, but it does some pretty sophisticated things under the hood in terms of fountain codes and things like that to be able to transmit larger quantities of data than a single QR code can normally hold. So in terms of all the things I've shown you with envelopes, what kind of data structure could do all this? It would have to be pretty complex, right? Well, let me show it to you. So here it is. This is written in Swift, but it's only slightly abbreviated, but here it is. So an envelope, a crypto envelope, has a subject and it has a number of assertions about the subject. That's an array of assertions, and that's it. Now, obviously, it's a little bit more complex than that because I haven't explained what a subject or an assertion is, but at a very high level, an envelope looks very simple because it is. So before we go too deeply into that, I want to start with a relevant example of this conversation. I want to show you how you would use this technology right now with running code that we currently have in Swift to use SSKR to shard a secret payload of any size and then share it with several parties for later recovery. So I'm going to show you a few lines of code. This will go by pretty quick. It's actually pretty simple code. So let's say we have Dan, who starts by creating a seed, something he wants to protect, and he adds several pieces of metadata to it: a name, a creation date, an arbitrary length note, and this makes it basically exceed the size that SSKR by itself can handle. So if he wants to actually shard this, then just a few lines of code will do it. He creates a content key, which is a symmetric key, and then he creates a set of envelopes by first encrypting the contents of that envelope with the content key, and then by splitting, and this is an SSKR specification, how many groups, what's the threshold group? So there's it's one group which has 3 shares, 2 of which is the threshold in that group, and then that content key is going to be used to recover the contents. So that's that second line there. The third line is just basically turning the group of envelopes into a flat map into a flat array of envelopes, and then the last line just converts them to URs. URs, as you're probably familiar, look like this. There are a URI, which is, URL is a kind of URI. It begins with UR : and then the type of UR it is, in this case, a crypto envelope. The rest is just text, and it's designed to basically be highly compressible into QR codes. Surprisingly, base64 is not the best way to do that. And then since we were targeting QR codes very heavily, we invented a system called bytewords to do that. So on the receiving side, we have these 3 envelopes sent URs 0, 1, and 2, and let's say that they were distributed to Alice, Bob, and Carol. But let's say that Dan only managed to recover the second 2 envelopes, Bob and Carol's envelopes, and that meets the quorum though. So in that case, he creates an array of the two envelopes, and then he recovers the seed. He basically tries to create an envelope with the shares and then extract the seed from that. And that works. Assuming that actually completes and doesn't throw an exception, it was a success. It's that simple. But let's talk about the actual shards themselves, or shares themselves. From a high level point of view, there's 3 of them, obviously, and they're all identical in terms of this one, except the contents of the SSKR share, which is different for each one. And all they are is an envelope which has a subject, which is the encrypted message, and then one assertion. The assertion says this is encrypted using SSKR, and here's one share. As I mentioned before, here's the envelope again. The subject is the encrypted message, and the assertions each assertion has 2 parts, a predicate and an object. So in this case, the predicate is the lowercase SSKR share, and the object is the uppercase SSKR share. So it says what this is, and this is one of the SSKR shares that this was split with, and here's the SSKR share itself. Now you notice that the definition of assertion here, that the predicate and object are themselves envelopes. And in fact, the subject itself, one of the possibilities is for it to be an envelope. So this is where we get the nesting, where we get the envelopes all the way down. But that's not generally, that's for more complex cases. For this simple case, you just have an envelope with, which is, nested 1 level deep. So let's look at the actual CBOR. Now, as you may know, URs are built on top of CBOR, the common binary object representation, which is kind of like JSON, but without the text. It's this binary. This looks similar to the simplified diagram I showed you earlier. It's an envelope with encrypted message, with 2 envelopes for the subject, for the predicate and the object, one of which says this is just an SSKR share, the other is the SSKR share. And if we kind of color code this, you can see that the encrypted message, which we've actually documented separately, it's a crypto message. You could create a UR with just a crypto message. It's encrypted using Csr poly. And the SSKR share, which we've also documented in our research paper. So these are pre-existing structures, but they happen to be enclosed in a crypto envelope. Now, as I mentioned, crypto envelope is actually a pretty simple structure, and we have a pretty robust library for constructing envelopes of any complexity. But if you were working on, say, an embedded system and you didn't want to, implement envelope in all its fullness, but you still want to read and write this particular structure, all the gray binary you see is just boilerplate, basically, in that case. And so you can actually just read and write just these bytes, and then just care about reading and writing the encrypted message and the SSKR share. And as I mentioned, there's 3 of these in this case, in a 2 of 3. And then you distribute those to the various custodians, gather them back, and then combine them using the SSKR algorithm. And that's the whole scenario right there. So I've really only touched briefly on kind of the high level concept of what crypto envelope is and can do. I want to make it definitely relevant to this conversation. There's a lot more it can do, but you don't need to worry about it if you don't need it. And so that's where I'll leave this. Thank you very much for your attention. If there's any questions, then I'll be happy to take some questions.
Just something I wanted to clarify, Wolf. Rather than just splitting the seed into shares and just sending the shares to individuals, this is a bigger object than just a share that's encrypted with a symmetric key, and the symmetric key is being split.
Yes, it's the symmetric key that's being split.
Right?
Yes.
Okay. Yeah. Perfect.
And the payload itself is encrypted using Csr poly.
Mm-hmm.
Mm-hmm. Okay, if there's no other questions, I'll turn it back over to Christopher.
Great, thank you. So, there's a lot of terminology that we've been throwing around here, and we're trying to be very consistent, and there's been back and forth. That being said, if we've got better answers that will work both from a technical point of view, but potentially from a marketing point of view, we're very open to that. We have, a lot of stuff we've thrown at you, and there's, more out there. So, but I think the key point that I wanted to make that Wolf did such a good job with at the end was you don't necessarily need to understand what all those bytes in gray do for you to be able to actually leverage and execute this. It is, our job to basically say, hey, we very carefully designed these to allow for more advanced scenarios and future-proof ourselves, because, we want to be able to do signatures. We want to be able to do certificates and verifiable credentials and presentations and the whole shebang. But we're really focused on one particular use case. So
yeah, and if you go read the crypto envelope documentation, I cover a lot of other possible use cases because we really wanted to think it through deeply. But ultimately, you only adopt it as far as you need it. The UR kit is another good example. Our fountain codes and so on, it's pretty much automatic. You give it an arbitrary block of data, it turns it into a series of URs that can be represented as QR codes efficiently. You don't need to worry about fountain codes or all that. We've taken care of adapting the algorithms and then establishing the binary format, and then, but interoperability is our goal. And so by adopting these technologies, you automatically gain interoperability.
So another thing that I want to be very cautious about, in the same way that some of our language may evolve. I mean, you'll hear later us talking about things called decks, and like nobody ever uses that word, but we needed something to have as a placeholder for a particular problem, and there'll be multiples of those. But in the same way you have those types of things, until there's at least two parties that want to ship something that's interoperable, the specs can change. I really want to avoid something that happened early on with our so-called PSBT 1.0, which was basically a proof of concept. We wanted to demonstrate, hey, here's a cool way we can do animated QRs. Are there people interested in it? And what ended up happening was two companies just basically said, yeah, we're shipping it. And it's like, wait, we're not done. So we ended up having two versions of the PSBT.
Actually, there's the UR specification. Yeah. There's a 1.0 and a 2.0, but yeah. So that was largely on me because I'm not a relative newcomer to the specifications world, and I didn't clearly mark my first specification as a draft, not for actual deployment at that time, because we had more on our roadmap.
Yep.
Not like that would have stopped anyone.
So any case, just be clear, we want feedback, and there's an opportunity for all of you to contribute to these and such. I did want to very briefly, before we kind of open up it broader, talk about kind of what what is our platform and such for talking about this. So so this is what is the collaborative seed recovery, what we call a community project issue. So this is in the Blockchain Commons community section in our issues. And so this is pretty much, where we ought to be tracking who's doing what and whatever. So I'm expecting over time, this could be quite a long thread of resources and updates and everything. But in general, we'll always try to keep this top section up to date. And so this is kind of a list of some of the things we currently think might need to be done, who's going to be involved is, maybe come out of this conversation. I'd love to know what your individual goals, that will do that today. And then we can talk about these other different kinds of things. And then obviously the key links. Sorry, all of these reside in our, we have all of our project management is in the community section section for all the different things that Blockchain Commons does. And we also have a project forum if you want to understand what our priorities are. But specific to this, Shannon Wolf and I have been working on this document for some time. So this is the summary of what is collaborative seed recovery, with an overview. We have some key principles that we believe that we are addressing with this, that we think meets everybody's needs. If there's some principle here that we're missing, some important design point that we're missing, we ought to know that sooner than later. We're really focused on being able to store secrets, be able to update them, and be able to recover. We have some what we call user key choice points that that we at least want to start with, and we can cover that in a little bit. And obviously, Wolf has shown the crypto envelope, and we have a variety of other technologies that permit all of this. We have a particular proposal to start off with that has a little bit of sophistication and does more than what people are doing today. And that is this particular set of things to allow for permits to be done. This may be greater, this is greater than a minimum viable product. So this isn't necessarily saying we're going to ship that immediately, but I think it expresses just a little bit of the richness of being able to do some interesting things. And, but also really importantly, what CSR does not do. So we have other emerging technologies we're working on that support collaborative key generation. This does not do that. The keys were generated somewhere, hopefully properly, we're also not trying to do collaborative key uses. This is not multi-sig. This is not, has some limitations. It is purely for recovery. You still have to protect your keys before they're split. We're not, this is not going to help with any of that. And once you've recovered your key, you're going to have to still protect it. We're not solving that problem. Again, we're not working with multi-sigs. Right now, other envelope permits, these are the things that unlock these secrets. We've got a lot of different use cases for other ways and reasons why you might want to unlock them. Right now, we're not specifying them. And then after some discussion with Simon, we believe, but we don't know for sure until we actually implement it, that envelope encryption using Csr Poly is the singular choice. There is performance reasons on some devices where that might be an issue. But the last time we talked about it, it felt like it might be reasonable. So we'll deal with that. We also have written up some extensive use cases that are presented progressively. These are linked at the top of these documents. So, the simplest use case is, somebody just got their app and keys were generated and keys were sharded and distributed, and the user was just totally unaware of that. So this could be the Autonomy app. They can instantly buy some NFTs or do whatever they need to do. They don't need to know that in fact it's safer and some redundancy was created and some resiliency was created. Obviously, at some point when those NFTs or proxy has some Bitcoin on the ring, you want to do, might advise that you do a security upgrade. We really want the security upgrade to be as painless as possible. So we talk a little bit about that. And then obviously, moving up into a wide variety of future scenarios, way beyond the scale of what we're going to be talking about implementing in the short term. But I wanted to hopefully everybody can read these and go, yeah, that makes sense for me. Or you missed an important use case. Like, I also want to shard my rings secret. And in order to do that, I need another kind of crypto envelope or another kind of, another kind of permit or something. And if that's critical for you and you want to ship that this fall or the beginning of 2023, we need to add another use case. We have also a bunch of other documents and whatever about the underlying technologies. So, back to the community project issue. Blockchain Commons goals is interoperability and creating a secure foundation. I really don't like, there are a number of people who already are sharding keys, Taurus. I know Block is planning on doing some kind of sharding with a third key and Bitcoin, but they're all proprietary. They're all single points of failure, not only in the fact that they're the only ones who provide that service. They're also single points of failure because they're only really listening to one party themselves. whereas we really want to first meet your needs, or ideally at least two parties' needs, so that you're not dependent on any one of us to make this a success. So that's what Blockchain Commons wants. I thought I'd go around the room again to sort of talk about what your thoughts are and why are you supporting Blockchain Commons in doing this, and what would you like to do? So I thought I'd start with Simon.
Yeah, the primary goal for us is a wallet user experience that doesn't suck for people who are not crypto nerds, right? We or many of us in this room probably are crypto nerds, and that's, you know, we can read these documents and we can understand how SSS works and what's the right way to protect these things, but we really want to bring some of the benefits of controlling your keys and controlling your digital identities and assets, etc., to everyone, because I think there are a lot of benefits, but we need to do it in a way that doesn't let people shoot themselves in the foot by doing it and then losing the keys or forgetting where they store things. So that's our primary goal, kind of as a company, to make this to make this wallet that's easy to use, and more importantly, easy to use correctly as a good default without having to understand how that actually functions. And just as importantly, difficult to use incorrectly, right? And difficult to screw up. So that's the goals overall. The goal for this kind of CSR SSKR conversation in particular is to have, so this is something that we're working on already. We have some implementations which use SSKR, and Jorge is working on some additional ways to store and distribute the shares. But eventually we would like this to be, well, firstly, a somewhat standardized way. I very much agree with Chris that everyone shouldn't be implementing their own. There should be just a standard format and a standard way of representing it. You know, whether it's crypto envelope, that seems perfectly reasonable. It's you know, integrated encryption scheme these have been around for a while. It also means that it has, as a company for us, this has a a twofold marketing benefit. One is we can confidently tell people, hey, don't worry about losing stuff. Don't worry about proxy going out of business. There's ways that you can still get to your data, and ways you can recover it. Hey, here's an open source tool that you can download and decrypt your personal vault, even if our app is not around, etc. Very much a true self-custody approach. And the second one is sort of a halo effect of as a user kind of coming to our app, asking, well, why, you know, you're recommending that I protect my keys in this particular fashion, or protect my wallet in this particular fashion. Like, why do you have authority to tell me how to do it? Having multiple people who have looked at it and sort of implemented it, having public documents that have been reviewed that we can point at and say, hey, this is best practices of how you should be doing these things, and our app implements these best practices. That's what I would like to get to.
Great. And as far as engineering team, you've got a couple of people that are already doing stuff with SSKR, not necessarily crypto envelope yet, but you envision that in the early 2023, maybe you can offer a public service to others to shard.
Yeah, and we're exactly, and as I said, we're building similar things, and we're using a lot of these things already, like SSKR, and we'll probably have some form of social recovery and